Okay, welcome back. What we want to look at today is level 3 NVQ. Okay, and again we're looking at unit 304, and this would be the EAL reference number. Okay, now we're looking at session 2 earthen systems, and this is still in connection with unit 304. Okay, now again I'm not going to read this out to you. Understanding the principles of planning and selection for the installation of electrotechnical equipment, etc., etc., etc. Okay, but now you need to be familiar with this, and again you need to extract the information in conjunction with the IEE regulations or IET regs. Now what I will be looking at trying to do here is to give you information frame by frame, okay, and telling you exactly what it is trying to look for, what you need to be doing. So you will need to make notes for yourselves. Don't just try to read it off the screen, okay? Although I try to make it as simple as possible to be able to do that. Okay. And we have the learning outcomes for this session, okay? The student will be able to gain an understanding of earthen systems. And I'm just moving to that, okay? I just move back out, make sure that it is fully in screen. Okay. Let me just try and change the angle a little bit. Okay, hopefully that will be better. Okay. Now earthing. Connecting to earth provides two things: a reference point against which we can measure our voltage. It also provides us with the means to clear line to earth faults by operating protective devices when sufficient current flows. These are essential in low voltage installations. Sorry, and this is where I am now. In the electrical system in the UK, it is the responsibility of the consumer and or the electrical contractor to make sure that an installation is adequately earthed. A means of earthing is, however, often provided by the distributor via their supply cable. On the ESQR, and it is ESQCR, and you will need to look up this in the health and safety regulations, okay, to see what ESQR is, and you should have done this already in unit 301, okay, and it's on my channel as well, so look it up. ESQR 2002, distributors are required to provide an earth for new installations unless there are safety reasons for refusing one. For existing installations, they may provide an earth, but discussions will have to take place with the local distributor. But as we know, that an earth normally comes in with your supply anyway, okay? So we can take that as read, but always be aware and check and double check, because if you are the installation guy doing that work, and you are meant to be the responsible electrician, it is your duty to make sure adequate earthing has been provided and tested. Remember one thing: safety, safety, safety. Now here we're looking at showing you the reference point in regards to a three-phase supply. This is delta, this is star. So your input coming in from your transformer side is always in delta, output will be in star. Okay, so let me just go in a little bit closer so that we can get everything on, and I'll pan back. Brown, blue, black, gray. Okay, now just pan out. Okay, now the star point of the distributor's transformer on the secondary side, low voltage side, neutral, is connected to or tied down to the earth, which is accepted as being 0 volts. On the primary of the distributor's transformer, high voltage HV, there is an earth provided, and this is connected to the structure of the transformer itself. But also remember that these transformers, although they're connected, bolted to the transformers are fixed to a structure which is concreted into the ground, and that is bolted down to that girder system. So you can be sure that you have got a good earthing in regards to your primary side of your transformer. Okay. Okay. And again, this is your reference point. Okay, it tells you there quite clearly. Now the earth fault loop. Now in the diagram I should say, we can see what is called the earth fault loop. The earth loop is the circuit which begins at a fault, passes through the earth conductor and into the sub mains, and then back to the point of fault. So what you're saying here, that an earth fault has occurred here. Okay, we know of the fault. It's going down, okay, going through our system and earth fault loop, and it's coming back to the point where it originated from. But remember that your protective devices should be in such a position that if a fault occurs, it will trip and protect your load, irrespective as to what that load may be. Okay, so earth fault loop impedance, and again ZE has to be taken into account because your earth fault loop impedance needs to be so low that it causes a high current to flow down to the ground, causing your protective device to function and protect your appliances. Okay. Now again, just want to make sure that I can get it all in, and that you can see everything. Let me see if I can get this into. Okay, good. Okay. Okay. Thank you. Now here we have types of earthing systems. Okay, types of earthing systems, and the regulation lists 5 types of earthing arrangements. Now, it is possible in future there might be others, but again, make sure you are in touch with the IEE regs or IET regulations, which is the Bible for the electrical contracting and electronics industry. Okay, so you have here TT systems, IT systems, TNS systems, TNC systems, and TNCS systems. Here we will consider the three most commonly used types in detail: TNCS, TNS, and TT systems. The IT system has a high impedance placed between earth and the star point of the transformer. This guarantees a limit fault current. In the UK, Electricity Safety, Quality and Continuity Regulations 2002 Esquire forbids the use of the TNC system. Okay, so bear that in mind. In the UK, we do not use the TNC system. Well, not yet anyway. Now here we have, what do the letters stand for? So first letter, earthen arrangement at the source, usually the supply transformer, TNCS. So T, source is directly connected to the earth at one or more points, usually star point of the transformer. N, second letter, earthen arrangement at the consumer's installation. N, exposed conductive paths connected directly to the source earth, usually via earthen and bonding conductors. Okay, just going so we can bring that up for you. Move across and bring that up also for you. Okay, other letters, how protective conductors and neutral conductors are dealt with at the consumer installation. Okay, so CS, neutral conductor and protective conductor combined in the supply cable and separated at the consumer's installation common. Okay, sorry about that. So let's just go back, pull back, make sure we can get everything in review. Okay, what do the letters stand for? Okay, now you should need to make this a note for yourselves as well. Okay, and that is paramount in your case. And again, the next part of what the letters stand for. Okay, TNS, T, source is directly connected to the earth at one or more points, usually star point of the transformer. IT, I, all source life paths are isolated from the earth or connected via a high impedance, rare and not used in a standard installation. Okay. N, T, S, etc. Now you can read these for yourselves. You don't need me to read them out to you. I'll make sure that they can be seen. Okay. Now you can make notes for yourselves based on this information. Okay. Okay. And again, the remaining of the letters. Okay. And you don't need me to take too long on this now for you. Okay, you should be familiar with this by now. Okay, let's just make sure that we can see and read the information in each case. Okay. Just pan back a bit. Okay. Make sure we can get everything in. Okay. And this is what your TNS system looks like. You'll notice here that your live goes through your meter. Okay, it's a solid neutral bar. Okay, your earth is linked to here. Okay, but you'll see that earthen conductor, earth block, is connected as one. Okay, this system has a combined neutral and earth. So here we're saying that your neutral and earth is connected together. So live, neutral, okay, and it's connected as one. What this has the effect of doing is actually creating a larger current to flow when a fault occurs on any of your appliances or on the circuit or any circuit. So rather than whereas before it was just a fault down to earth, because it's now seen as a short circuit, that short circuit effect causes more current to flow, thereby tripping your devices quicker. Okay. Just move across here so you can see this and read this for yourselves. Okay. In full. Let me just move in to here. Okay. So you can see the connections. And this is still wired armor cable. Okay. The size is dependent upon what current you're going to carry, so you'll be looking at 100 amps normally for a household. Let me just come back so we can make sure we get everything in view. Okay, an example of this type of supply arrangement would be PME, protective multiple earthen, or PNB, protective mutual bonding. Okay. Okay. And this is protective multiple earthen. Okay, all it's showing you here is that PME is similar to the one we just have, where the neutral is bonded down to earth. Okay, main earthen terminal. Okay, MET, general massive earth. But it's also showing you that in some cases you can use electrodes to create that effect as well. Okay, and you'll see even more so where electrodes come into their own in regards to a TC system as well. Okay, now I don't need to read this for you. I'm going to make sure you can read this for yourselves. Okay, sorry about that. Just move in so you can see what has been said. Okay. Okay. Pan back, make sure we can get everything in. Now TNS. This has a separate earth from the supply transformer to the installation, and in the installation there is a separate neutral and protective conductor. Okay, so let me just move into this, make sure you can see this and read this for yourselves in full. Okay, because it matters tremendously. A TNS system usually has an external earth loop impedance of 0.80 ohms, quoted by the distributor for both single and three-phase supplies. Okay, so you've been given an earthen value already here of resistance. So I'll just pan back a bit now so we can get everything in, okay? Okay. And here again you have your neutral, separate neutral, and your separate earth, okay? And it's bonded to the steel wire armored. Okay. Just checking that we can see the bottom information as well. Okay, let's go down and make sure we got everything in place. Okay, thank you. Good. Go back a bit. Okay, thank you. Here we are with our TT system. Now let me just bring this here first to you, okay? Make sure I can bring it up. Let's go up a little bit to make sure I can get everything into play. Okay, this system has no earth provided by the distributor. The consumer must provide their own earth via an earth electrode and RCD to make sure that the voltage appearing between bonded metalwork and wet floors, etc. does not give rise to risk of shock. The figure for the external earth loop would be 21 ohms, or even lower if possible. This type of system can be an overhead supply system, type that is commonly found in farms, etc. Okay. So let me just now pan back out. Okay. Go down, and here we have, and this is our TT system. Okay. Let's go back in full so we can get it all in full screen. Now let me go back in again now to show you where. Now here we have the electrode, and the electrode would be, earth electrode would be connected from your consumer unit, and it would go to a earth rod. Now remember, you may need to change or put in alternative earth rods at certain values that give you the best resistance that does not exceed this value, okay? And that's what you're looking for. So anything below that, you know that you're in good hands. Now don't get doing what some people do, wet the ground and to get a better earth connection, because when the ground then dries out, then you're going to have a massive increase in resistance which will exceed that value, which would then will not operate your protective device, okay? So you need to be sure that your earth electrodes will have variations so that they can find the best point at any point in time, whether the ground is wet or whether it is dry. Normally we used to put in a copper plate, so you'll find that sometimes you would solder a copper plate and you will set that into the ground. Basically it'll be about maybe 12 inches square, 12 inches by 12 inches copper plate set into the ground, basically. But bear in mind the options for the IET regs, what it stipulates and what it tells you what you need to be doing, and that is your Bible that you need to comply with at all times, okay? Again, safety, safety, safety. And that's our TT system. This is your most important bit in regards to your TC system. Now remember, this cable here has to be for reasonable size. Okay. Okay, thank you. Now this is our TC system, and this is just showing you a supply that comes in from the farm. Let's go and read the text, okay? You can read the text here for yourselves. I don't need to read that for you, okay? Even though the TC system is most commonly provided for installations such as farms and villages, it can also be found in installations such as petrol stations where a TNCS system is not allowed to be used, okay? Okay, multiple choice questions. Now do the questions. All the correct answers is in the text. Read the text, look back at the work, okay? Answer the questions. Okay, that will be it. Thank you. I hope you found this information useful at all times, okay? And I'm just gonna make sure we got it all in, okay? Come back a bit. Yes, we have. Okay. Thank you for your time. Have a very good day. Bye-bye for now.